Problem F13-15. The 2 megagram car is traveling along a curved road described by R equals 50 e to the 2 theta. That's written in here, but it's kind of hard to see. Where theta is in radians. If a camera is located at A and rotates with an angular velocity of 0.05 and an angular acceleration of 0.01, at the instant theta equals pi over 6, determine the resultant force developed between the tires and the road at this instant. So in order to find, the tires are creating the acceleration. So what we need to do is find the acceleration of the car. Now this is a problem where R is not this is the radius of the road, but this distance is not the radius of curvature. And so we need to use the equations from 12.8, I believe, where we have AR equals R theta dot, and A theta equals R theta double dot plus 2R dot theta dot. So if we solve these two equations, we can get the radius, get the magnitude of those two, and do F equals ma. So starting with the equation, R equals 50 e to the 2 theta. We need R, we got there. We need R dot, so we'll take the first derivative. We need theta and theta double dot, which will come from those, and they're also defined there at that instant. So we'll take the derivative first, and the first derivative, R, is equal to 50 e to the 2 theta. That's the derivative of the outside. The derivative of the inside is 2 theta dot. Now if we take the second derivative, we get R double dot is equal to 50 e to the 2 theta. We take the derivative of this first, 2 theta dot, and I have this 2 theta dot still on there, product rule, squared, plus the first part, 50 e to the 2 theta, derivative of the second part, 2 theta double dot. So at this point, at that instant, theta is equal to pi over 6. Theta dot is equal to 0.05 radians per second. And theta double dot is equal to 0.01 radians per second squared. So substituting these three values into R, we get R is equal to 50 e to the 2 pi over 6, which is 142.5. R dot is equal to 50 e to the 2 times pi over 6 times 2 times 0.05. And that is equal to 14.25. And then we have our double dot, which is 50 e to the 2 pi over 6 times 4 times theta dot 0.05 squared plus 50 e to the 2 pi over 6 times 2 times 0.01, and that results in 4.275. Putting these values into there, AR is equal to R 142.5. Oh, this equation isn't quite right. That should be R double dot minus R theta dot squared. That's better. So 142 minus, no, not 142, 4.275 minus R 142 times theta dot squared, 0.05 squared, and that is equal to 4.275. Nope. 3.919 meters per second squared. Now A theta is equal to R 142.5 times theta double dot 0.01 minus 2 R 14.25 times theta dot 0.05, and that is equal to 2.85 meters per second squared. So the magnitude of A is the square root of 3.919 squared plus 2.85 squared, which equals 4.85. F equals MA, and we have the mass of the car is 2,000 kilograms, and the A is 4.85, and the force is 9,700 newtons.